Good evening, my YouTube viewers. In this series of videos, we're going to be talking about time series analysis. So time series analysis is a part of statistics, but it has moved over to machine learning as well. So some people may be familiar with time series analysis as it relates to machine learning, but it was part of statistics before it was part of machine learning. And Python has a library called stats models, and in stats models there are quite a few models for time series. But one thing that I will say about stats models is the documentation for stats models, in my opinion, is not as good as the documentation for sklearn. So stats models is a statistical library, but sklearn is a machine learning library. But some of the functions in stats models also appear in sklearn, such as linear regression and logistic regression. So that's just something to keep in mind. So now that you know that time series analysis is actually part of statistics, then what we're going to do is we're going to do a practice question. So we're going to use seasonality of daily temperature. And what this is seasonality is regular repeating patterns or cycles in the data, often tied to specific times, such as months, days, or quarters. So in order to write this program in Python, first thing that we have to do is we have to import three libraries. So we're going to import NumPy as NP, which is the numeric library, and we're going to import pandas as PD as the data processing library that also creates data frames. And we're going to import matplotlib.pyplot as PLT as the visualization library. So what we're going to do now is we're going to generate synthetic daily temperature data for 1 year or 365 days. So the first thing that we want to do is we want to set our seed. The reason why we set our seed is so every time you run the program, it will initialize to the same values. So we set our seed by typing np.random.seed, and you can put any number that you want inside the brackets. And so days equals an NP array of 1 to 366. So now we're going to create the seasonality, which is a sinusoidal pattern to reflect seasonal changes. Amplitude equals 15. Baseline temperature equals 20. And seasonal pattern equals amplitude times np.sine brackets 2 times np.pi times days divided by 365 plus baseline temperature. So now we're going to add random noise to simulate daily temperature variations. Noise equals np.random.normal, and normal is a normal distribution, bracket 0, 2, len days, and it's 365 days. And so that's Gaussian noise with a mean 0 and standard deviation of 2. Daily temperatures equal seasonal pattern plus noise. So we're going to create a pandas data frame for time series analysis. Temperature data equals pd.dataframe, brackets, curly brackets, day colon days, comma, temperature colon daily temperatures. So one column is for days and the second column is for daily temperatures. So now we're going to plot synthetic temperature data. plt.figure brackets fig size equals brackets 6, 4. plt.plot brackets temperature data square brackets day, temperature data square brackets temperature. comma, label is daily temperature, color equals blue, alpha equals 0.7. Then plt.plot, brackets, temperature data, square brackets, day, comma, seasonal pattern, comma, label equals seasonal pattern, no noise, comma, color equals red, line style equals dash. So we're going to label the graph and give it a legend. So the label of the graph is daily temperature over a year, simulated with seasonality. The X label is day of the year. Y label is temperature. You get a legend and you get a grid. So we're going to show it. So daily temperature over a year, simulated seasonality. So the blue line is your daily temperature, and you can see that the daily temperature changes every day for 365 days. And then the red dashed line is your seasonal pattern. So that concludes this video on seasonality. In the next video, we will cover another time series subject, and I hope you decide to watch it.